What I would like to do first is to introduce Mr. Ueda. He is chairman and president of ClassNK Japan. I'm told he only landed a few hours ago from Japan, so it's a very sturdy performance to come here to open this. And he's also vice chairman of the IX Council. Mr. Ueda, can I ask you to introduce our speaker and introduce the general lecture, as it were. Yoichi-san.
Thank you very much. Good evening, ladies and gentlemen. On behalf of everyone at ClassNK, I'd like to extend a warm welcome to you all here tonight. I'd also like to take this opportunity to express my thanks and appreciation to IMarEST, which for more than 120 years has played a leading role in ensuring the growth and safety of the world maritime industry. With this lecture series, IMarEST continues to fulfill this mission by providing the deep knowledge and insight that will be necessary for our success as an industry in the years to come. And it is in that spirit that we are proud to be able to sponsor this prestigious event again tonight. As you all know, these are still trying times for our industry. While the world economy has begun to recover from its most recent economic crisis, for the maritime industry, many challenges remain on the horizon. From new regulations to the high price of bunker fuel, to the challenge of creating a new generation of greener and more efficient merchant vessels. While great progress is being made, there is still much to be done, and there exist many questions that we must try and answer. It is to address these questions and answers that we have invited Dr. Martin Stopford to be our lecturer this evening. As you may know, Dr. Stopford is a graduate of Oxford University and has a PhD in international economics from London University. In his 35 years in the maritime industry, he held positions as Director of Business Development at the British Shipbuilders Corporation, Global Shipping Economist with Chase Manhattan Bank, and the Chief Executive of Lloyd's Maritime Information Services. However, he is perhaps most well known for his position as Managing Director of Clarkson Research Services Limited and Executive Director of Clarkson PLC. Although he stepped down from these positions earlier this year, he remained President of Clarkson Research Services and is recognized throughout the world as one of our industry's brightest minds, top economists, and among its finest speakers. Ladies and gentlemen, Dr. Martin Stopford.
Well, thank you very much, Chairman, and Ueda-san, for that very generous introduction. It's really a great honor to be invited to give this lecture for ClassNK and for IMarEST, both very august organizations. And I think it's very brave of them to invite an economist to address you, having spent the day listening to some quite erudite engineering in the next room. I think you're extremely brave. I started off with a ship, you know, because we've had quite a debate this afternoon about gas ships and gas pipes, and it reminded me that just about 32 years ago to the day, the industry was totally preoccupied with another fuel crisis. I mean, the oil price was much the same. Energy was absolutely on the agenda, and in those days, briefly, there was an enormous enthusiasm for coal-fired ships. I mean, I myself gave a paper on coal-fired ships at a conference, and for about 2 days was an expert in coal-fired ships. But anyway, as a result of this, 2 coal-fired ships actually were ordered, and here they are. They were, I believe, classed by ClassNK. They were built. This is the River Boyne, built for ANL. It was on trials built in Mitsubishi, and you can see the bunkering hatches. Well, actually, the ships did perform very well. They were in the Australian trade, built for the for bauxite or for alumina, I think, on the coastal trade, and they did trade to Japan with coal. But I think, you know, it shows that there's always room for innovation in shipping, but it doesn't always work out because these were the only 2. But they did last 28 years, and the River Boyne was scrapped about 5 months ago. So I thought there's a nice symmetry in that. Anyway, on to my main theme this evening, and that is, can shipping meet the challenge of change this time, and can we do a bit better than coal-fired ships this time? And that's what I'm going to talk to you about. I'll just to give you a quick preview of how I'm going to structure this, so you're not too surprised as the bits come through. I'll start off with the challenge and talk a little bit about what the nature of the challenge is from an economic point of view, because I think the theme that I want to develop this evening is the relationship between the technical details of what we do in this industry to develop effective ships and the economic framework within which those ships are conceived, tested, and finally trade for 25 or 30 years. And it's not an easy thing to do. And in order to put this into perspective, I'm going to focus on the fossil fuel issue. I'm setting aside regulations, not because they're not important, but you know, regulations are there to be obeyed. IMO makes rules that we have to obey, and I guess the technology has to be found to do that. But what we're really concerned with, and as an economist I'm really concerned, is how we move the industry forward in a positive commercial way. How do we make shipping better, not just safer, but better at what it does? And I think that there's no doubt about it that we are still very much in the era of fossil fuels in shipping. And just to put that into perspective, I've got 2 sessions. The first, I'm going to talk about the way fossil fuels first came into the shipping industry, not for too long, but just to give you a perspective of the nature of the developments at that time. And then the major change that took place about 50 years ago, and which really created the world in which we're building and for which we're building ships today. And then I'll move on to, of course, the great issue that came out of that was not really fuel, but economies of scale. I would say fuel efficiency has been, for the last 50 years, a very neglected topic. And I think in some ways that's good because it leaves lots of opportunities. And then I'll get on to my final session, which is the cost strategy, and I'll tell you what that is later on. But anyway, the answer to the question, how do we prevent the great white hope becoming the great white elephant, is pay attention to economics as well as technology. That's my theme. Now, let's start with the challenge. I think there's no doubt about it. The shipping industry has been enormously successful in the last 50 years. Just look what it's done. We've gone from a billion tons of cargo in '62 to 9 billion tons of cargo today, which is getting on for 1.5 tons for every single man, woman, and child in the world. It's moved effortlessly. Most people don't even know it's moving. not only has the industry done that, if you look at the cost of moving a barrel of oil from the Middle East to the North Atlantic, that's represented by this blue line with red dots, and that has been fluctuating around $1 a barrel since 1947. Now, I haven't inflation adjusted these figures. That's $1 a barrel. I think if you go and look at the price of a motor car or anything else in 1947, I think a motor car cost about £200 in this country in 1947, and it costs, I don't know, I haven't bought one recently, £10,000 today. So I think the shipping industry has done very well economically. We've also made a few mistakes. I mean, this is the Bacillus, the world's biggest tanker, which did about 25 voyages and then disappeared into the scrapyard in 1985, I think it was. So, and there was quite a few other ships that didn't work out. You know, I mean, the sort of things that we get very interested in as an industry often are not the things that work out best. A lot of the most important things are the bread and butter bits and things that you do that involve applied, carefully applied principles over a period of time. You may remember lash ships, which were an enormous source of enthusiasm in the late 1960s. Pallet carriers, I believe that actually Maersk was a great fan of pallet carriers and not interested in containers at all, actually, until about the mid-1970s or the early 70s. Combined carriers, a wonderful idea that failed on the economics, and yet one of the most successful ships, 400 or 500 of them built, was the SD-14, and having been involved in building them, I can tell you they were very good ships. But they did a basic job effectively. You know, and I think the first SD-14 was designed down to a price, and to get to that price, they took out the deck heads and they took out everything that moved to get it down to a price, I think, of $750,000. That was what they were after. So, you know, when the challenge is not to get preoccupied with clever ideas. The challenge is to look at the detail that we need to look at in order to move forward and continue those very successful trends which the industry has achieved so far. Now, at the heart of, I would argue very strongly that at the heart of all of this, for us today, there is only one issue of any significance, and it's fossil fuels. For the last 200 years, the shipping industry has been transformed, and of course we've been quite clever. Engineers have been quite clever, naval architects have been quite clever, but really they've been clever because there's been an enormous source of energy which has made it possible to do things that you wouldn't have believed possible before it came along. Just to illustrate this, it's not a shipping example, but I think it's quite a good one. This is, since I'm interested in farming at the moment, this is a reaping machine in 1790, you know. I mean, this guy might have done a few square yards of, maybe he did I don't know, he might have done this bit in a day. Now, today, reaping machine, same two men, 200 acres, 300 acres, and all sorts of information. So, I mean, that is not technology, that is fossil fuels. This guy was one manpower. This tractor is probably, I don't know, 3,000 manpower. I don't know what it is. But that principle. Shipping before fossil fuels was a very primitive business. It relied entirely on the energy we could get from the wind. And this is the Pool of London. You could pretty well where we're sitting now, actually, if you looked out the window. This is what you would have seen in 1790. You couldn't take these, you couldn't build them much bigger because they're wooden hulls and you're reaching the limits of what you can do with wood. And if you sailed down the Thames, you might be sitting for 3 weeks waiting for a wind to get you out of the Thames, you know. The hard handling of cargo was enormously tedious. I mean, even with a crane, it took 4 or 5 men to lift this little bundle onto the ship. And yet, when fossil fuels came along, within 40 years, We got 10 ships which were 10 times bigger. This is the Agamemnon, Alfred Holt's first liner ship, and an enormously successful vessel. 900 horsepower, totally modern, 10 times bigger, 10 times faster. An enormous change in productivity. I mean, if you sit down and do the numbers, this is into territory that we don't even dream of today. It was a step change. Take another step on, and we've got a ship which is 50 times bigger and 2.5 times as fast. So it's not such a big change, perhaps, but it's an enormous change. And if you look at what's sitting inside this, it's an engine. And that engine, 109 horsepower, that does the work of 3 million men, basically. And it would take a town the size of Greater Manchester to house them if you wanted to house them. So, you know, the fossil fuel is not just giving you an enormous amount of power, it's giving you power that you can keep very conveniently in a nice little tank on your ship. And actually, they'd eat 9 billion calories a day if you were to power this ship by men. So I think, you know, you'd need some bulk carriers going along behind to carry their breakfast, lunch, and dinner. I mean, you know, I think to some extent we've lost sight of the reality of what fossil fuels are giving us. And if you look at seaborne trade before fossil fuels, it was 20 million tons, and seaborne trade after fossil fuels is 9 billion tons. And there is no way, however good your technology, you couldn't do this without fossil fuels. Now, I don't need to give you really a lecture on fossil fuels. That's not what it's all about. But the fossil fuels do, of course, bring the environmental footprint issue. It is part and parcel of the same thing. And for example, this is the installed kilowatts of the various parts of the merchant shipping fleet. Currently, the container fleet's 121 million kilowatts, which is pretty close to the installed capacity of the German power industry. So, you know, it is a big player. We all know that's part of the global footprint. And as part of the focus on fossil fuels, naturally, we have to think about the footprint, the carbon footprint. I don't want to focus on that too much, but it goes very much in parallel with the issues of saving this energy, because the challenge is to use the source of fossil fuels more effectively in future. And what I'm going to suggest, for reasons to do with the history of the industry, that we haven't really so far started trying all that hard to save fossil fuels. It's a very useful and valuable resource, but maybe we haven't put as much technology into it as we should be doing. The trade today, as I just mentioned, is 9 billion tons. Actually, most of that is imported by the OECD countries, a big chunk of it, over half. And we have a large part of the population which doesn't import very much. If you continue some sort of geopolitical extrapolation of the trade growth of recent years, then in 2050, without being very aggressive about the growth rate, we'll be looking at seaborne trade of 27 billion tons. And I don't think, sitting here today, you could realistically say that the industry should be looking at moving that amount of cargo without making some very significant improvements in the use of energy in the transportation of that cargo. It's too precious. I think this is a challenge that has to be addressed. Well, we're coming after, following on perhaps from two generations or two periods of technical development when fossil fuels actually were brought into the shipping industry. And I wanted to say a little bit about them because I think that by looking at where we've come from, you get a sense of where we're going to go in the next stage. I mean, I've got an idea about where I think we ought to go in the next stage, but I reckon you need a perspective. And the first stage of fossil fuels, the way I like to look at it is from about the 1870s, when steel shipbuilding first became a well-established discipline. I mean, by this stage, you had the compound steam engine, which was efficient enough to leave plenty of space for cargo in the ship. You had steel hulls beginning to come in, and you had the propeller had very rapidly taken over from paddle wheels. And so you effectively had modern ship design available from about the late 1860s, early 1870s. The key thing at this time, I think, and this is important when you look at the technology, is that the way the shipping industry developed was not actually primarily driven by technology. It was actually driven by the way the world trade was organized at that time, because at that time, the world was effectively organized into empires. And this map, I won't bore you with it, but great parts of the trading world were effectively controlled by the European imperial powers. And the shipping industry was actually designed around the requirements of an empire. And what you got was a very distinctive shipping system. You have all the cargoes, the sort of things we have today, except we don't have many passengers today. And the way they carried this cargo, well, it was lots of different empires, lots of different colonies, many different ports. What you needed was to carry general cargo and passengers out, and to come back with raw materials. That was the nature of the trade. And to do that, you had to visit many small ports. And so what you needed was cargo liners that could take the passengers and the more valuable cargo out. You needed tramps, which could supplement the cargo liners as and when required. And when not required, they could carry the bulk cargoes that were needed, perhaps maybe taking bunker coal out to the bunkering stations around the world and returning from the colonies with bulk cargo. And all of this meant that the ships that we had during this period were quite small, about 10 to 15,000 tons was typical here. That wasn't because they couldn't build big ships. I mean, the third strand was the great passenger liners, which by 1914, these ships, which were dedicated to the transport of people, had reached 1,000 feet long and could cross the Atlantic at, I forget what the Titanic did, but you were knocking 30 knots. So there's no question that you couldn't have built big ships, but actually we served the empire with small ships in this tightly knit system. And we had a period during this up to about 1900 when there was a lot of technical development, and we started to build ships that were designed to carry these trades. Well, I think there was another technical undercurrent in this period. The main framework of shipping was set by the empires and produced the liner and tramp system. But the subplot, which ran for the whole period, nearly 100 years, was the battle between wind and fossil fuels. Because at this time, the steamships actually didn't have a total monopoly on trade. And for 80 years, we saw this battle between steam and sail. In retrospect, it was a foregone conclusion. I don't think there was any chance, looking back, that sail would have won. I mean, it doesn't seem possible in retrospect. The steamships, however, did have some problems. They had to use expensive coal, whereas wind was free. The machinery was expensive, and the whole vessel was very capital intensive, and you really needed to move fast. You couldn't hang around waiting for cargo. In contrast, the sailing ships very quickly adapted all of the technology that came with steel shipbuilding. So you got the best sailing ships ever were built during 1910, 1911. And these had steel hulls, they had steel masts, wire cables, and they were built to be the most efficient ships that you could possibly build, and they fought it out. And the reason I put put this in is that you might wonder afterwards, why did the industry devote so many resources to building the world's, these wonderful ships, which were massively efficient? They would do 16 knots. But if there was no wind, they didn't do any knots. And in today's world, that was a big problem. And I think it says a lot about our attitude to ships in the industry, that we love the ships and we become very preoccupied with them. But sometimes it gets in the way of clear-sighted business. The last sailing ship was not actually taken out of service. It was Gustav Ericsson in 1947. In fact, according to the book I was reading, Clarkson's, he accused Clarkson's of trying to put him out of business in the 30s. So, and this, of course, was the future. So I think one of the messages out of this period is that you really have to look at the environment, the economic and geopolitical environment, before you get too hung up on making your decisions about what sort of ships you're going to build and how you're going to design them. And secondly, you do have to be careful not to get too preoccupied with the ships themselves. In the end, they are just the hardware that helps us to carry on our business. Well, okay, let's go on to the next period, because I think this started in 1950, or 1944 actually, when the Americans, to all intents and purposes, invented globalization. They called a Conference of the Allies at Bretton Woods Mount Washington Hotel in the States, and they announced, Henry Morgenthau, the Treasury Secretary, announced that they were going to, that after the war, that it was going to be a free trade world, a global free trade world. I think this was because, that every time Coca-Cola wanted to set up a bottling plant in Nigeria in the 1930s, some toffee-nosed Brit civil servant told them to clear off, and I think they decided that they weren't going to have any more of that. So anyway, one way or the other, the world was globalized, and the imperial system was totally dismantled in the 1950s. I mean, it's all gone. All the colonies disappeared in the 50s. With that went the ship design straitjacket. When you think about it, that imperial trade had forced you to have small ships that were interfaced, very complex ships. You needed to be able to carry everything. It was a very compartmentalized business. Suddenly you open up the whole world and you can go anywhere. And that actually gave us a completely different shipping system. This is just some pictures of, that's the picture of the meeting at Bretton Woods. And the dynamic world economy really did need a dynamic shipping system. The two go hand in hand. That's not to say shipping made the global world economy, but you certainly couldn't have had the global economy without it. And the result was a flood of trade. Over the period since 1950, the world economy has expanded to 8 times its level in 1950. This amount of trade has increased to 16 times, so sea trade has been growing twice as fast. You've got your lumps in it, which are pretty nasty. I think, we all have a bit of scar tissue from some of these bumps here, but they're just bumps along the way. And it is, it's an act of faith. You either believe it or you don't, that this has got another 50 years to go. I think it's got another 50 years to go myself. And that's part of the challenge for what we do with the shipping industry going forward. Of course, the liner and tramp system, once you get into globalization, was dead meat, really. I mean, you can't run a global world doing this sort of thing. I mean, packing general cargo, you probably can't see it, actually, because my thing, but, I mean, this is just people. It's actually a Life Hug ship in 1954, and they're stacking general cargo into the hold with dunnage. By the end of the 1950s, the average general cargo ship doing this sort of thing was spending half its time in port. Everybody knows that. What we developed was a totally brand new shipping model which got out of the straitjacket of the liner and tramp system and went into specialization. So you have specialized bulk shipping for the bulk cargoes. You turn general cargo into a bulk cargo. I mean, a container is the world's most perfect bulk cargo, really. So you get all the bulk unitization things there. You standardize the specialized ships, and of course you get a bit of air freight in the end. But at the heart of all of this was not, although we're still trading off energy economics, at the heart of this stage, oh yeah, oh, you got it, yeah, I forgot about that. I've been reading that P&I Club report as well, you know, you guys, they were probably changing fuel halfway up the time, you know. No, this was a famous picture of Swan Hunter's VLCC that they built, the Tyne Pride, you know. So it actually didn't run into the houses, it was being built. Anyway, but I think that, you know, the economies of scale curve, once you break out of 10,000-ton ships or 15,000-ton ships, then you can get 50% savings. I mean, you can fiddle around with your engines till you're blue in the face. You're not going to get 50% savings. You might get 3% savings. So economies of scale was really, really important. And the shipping industry went for it in a big way. This is the average size of ships from 1963. This is going to the 70s. And so you see they're sort of creeping up in size, especially tankers. Tankers overdid it. They actually overshot the mark. But the other sizes did all creep up quite gently over this period. And you'll notice, incidentally, that during the boom in the last decade, we had a bit of a surge of size. That is absolutely very typical. During booms, during very profitable booms, people have a sort of built-in tendency to order bigger ships. I don't know why, but it's just part of this sort of investment psychology. And I would expect that to sort of start to come back onto trend a little bit later on. But the key point is not really that, but the key point is that this is where the shipping industry got its massive improvements in efficiency from. And it happened at all sizes. It wasn't just very big ships replacing very small ships. We ended up with these nicely balanced fleets with, you know, the products tankers, the Panamax tankers, the Aframax, Suezmax, VLCCs, you know, all with a significant share, all getting bigger. I mean, the biggest savings are the ones you get at the small ships. The big ones, the curve starts to go asymptotic. Bulk carriers, exactly the same thing. We've now got 40% Cape, 26% Panamax, 21% Handy, 13% Handymax, and 13% Handy. And the containers, this looks very focused on the big ships in containers, 65%. But when I did this chart last night, I just couldn't lay hands on a breakdown of the post-Panamax container ships, whereas really that should be split into a couple of different categories. But generally speaking, you know, the story of the last 50 years is the story of these size groups emerging, of ships of every size getting bigger with each generation, and with each size increase becoming more cost effective. Well, so that's that. So I'm sort of telling you, although I started off saying my focus was energy, I've suddenly said, actually, in the globalization era, we made the big savings in shipping out of size, and no doubt will continue to do that. But I'm now coming back to the energy focus. And although the economies of scale are going to continue, I think when you start to look at the numbers, energy is back on the agenda in a way that it hasn't been on the agenda for a very long time. We had a sort of dress rehearsal in the early 80s, and there was quite a few things done in the early 80s. In fact, it was quite nostalgic sitting in there today and hearing shaft generators and waste heat recovery systems and all these things that used to happen when I was a young man, you know. And then all the people who spent money on them wished they hadn't, which is the, I mean, it is a problem. The ships that, if you look at the chart, and this is where we start to get into problems. This is the price of oil. Not in market prices, it's deflated. It's in, courtesy of BP. This is the price of oil annually back to 1861 in 2011 prices. So you can compare the prices at any level. So it was $110 a barrel in 1861 when its main competitor was whale oil, actually, at that time. You can see quite clearly that the price went down until the early 1970s. And I think I'll come back to this. Oil was very, very cheap for a very, very long time. And that influenced most of the globalization era, had very cheap oil. Then we had this spike of oil prices in the 70s and 80s, and that triggered a lot of interest in the shipping industry about building fuel-efficient ships. And quite a few people went in for fuel-efficient ships. They built, you know, Suezmax tankers with small engines that would do 13 knots, and they put all sorts of expensive gear like waste heat economizers and shaft generators in. And, you know, the trouble is in 1985, just as they took delivery of the ships, the price of oil went down again, and these eco ships became very hard to sell. I mean, who wants a 13-knot Suezmax tanker? For very good reason, because actually, in 2008, when the ship was chartering for $180,000 a day, you don't want 13 knots. You want 17 or 18 knots. You want to be able to get along and make money while you can. So the whole concept of let's design a cheap, and this is, I'm going to come back to, I was delighted to hear Captain Cooper's session later this afternoon, because I'm going to come back to pick up a lot of his themes here. We had this very enthusiastic period. Many of the issues the same. It was a complete, the phrase actually, the great white elephant, I borrowed not from Eric Scheuer from Gibson's, who said it in 1982. He said, make sure it doesn't turn into a white elephant. And that's where that phrase came from, and he was spot on. Those ships were white elephants. And now we've got another spike, and I think that, you know, there's a sort of vestigial memory in the industry of those times, and this is making people very suspicious of the whole eco-ship concept. And I think that justifiably, I think there is some, you know, the tone of a lot of the debate about eco-ships does lead you to the 13-knot Suezmax tanker with all sorts of, you know, with a great big gubbin stuck on it to get the sulfur out of the gas. And I think that is not necessarily the right way to approach this issue. But anyway, let me just, before I get to my hypothesis of what is the right way to do it, which I'm sure you know I'm going to tell you, since it's not a forecast, let me just say a word or two about what happened with fuel economy in the last 50 years, because, and perhaps to put this into perspective, what I did in this analysis was I've set up a concept that I think is absolutely central to the whole debate that's been going on today and the whole debate about eco-ships. And it is to look at the issue of energy in shipping, not as the fuel consumption of the ship, but as a comparison of the cost of the ship and the cost of the fuel. Those are the two main ingredients of moving cargo. It's the cost of the ship and the cost of the fuel. And what I've done here is to work out from 1976 the cost of the ship for an Aframax tanker. And I did that in a very simple way. I just took an Aframax tanker trading 350 days a year at the 1-year time charter rate during the year. And if you do that, this is the total revenue in ship cost. That's the cost of the ship in $1 million a year. So in 1980, it cost $4.2 million to hire a ship for 365 days on the one-year time charter market, okay? So that's the cost of the ship. The other cost is the cost of fuel. And if you look back at what this says is in 1998, the cost of fuel for that Aframax, trading at 15 knots, I put it up here, didn't I, somewhere? It's trading at 15 knots on a 5,000-mile round voyage. I forget what the consumption I used was, but basically the cost of the fuel is about $1 million. So you're paying $4, $5, $6 million for your ship, $1 million for your fuel, and that was the case really. That was the case for most of the period until about 5 years ago. Now, 5 years ago, we suddenly get this curve going up very rapidly, but to begin with, nobody really noticed because the cost of the ship was going up even faster. It was quite a, it was sort of fortuitous that the increase in the cost of the fuel happened at exactly the same time as we got into this outrageously expensive market for ships. And so it was really only in the last 2 or 3 years that the cost of ships has come down, the cost of bunkers has continued to go up, and so now, as of 2012, for the first time, there's a little bit there, just touched it in 1985, but for the first time in the history of modern globalization, you're paying more for your fuel than your ship. And that, in my book, this is a major economic change. And what we're talking about here is how you balance your use of the ship and your use of fuel and how you work between those two. Incidentally, I've just put, this is just showing the bunkers as a percentage of the total cost in the previous analysis. And today, the bunkers are 61% of the cost. And that compares with 11%. Makes a difference, doesn't it? So, did ships get more efficient? Well, what I thought, this is not great science, but I thought I'll just see whether they did. And I pulled out of our the Clarkson research database 172 20,000-ton bulk carriers, because ships seem to get more efficient, but of course they did because they're getting bigger. And one of the benefits of economies of scale is you get more efficient fuel. But what I want to know is, are the actual ships of the same size getting more efficient? And so I took out 20,000-ton bulk carriers, and I adjusted them all to standard speed of 14.5 knots, if I remember rightly, yes. And I did that just using the cube rule. It wasn't it's a minor adjustment to the consumption. And I then also adjusted for the dead weight, because there were small differences in dead weight. Some of them were 18,000 tons, some of them were 21,000 tons. And out of that, I worked out the bunker consumption in grams per dead weight per day. It works out as 1.3 kilograms per dead weight per day for the 20,000-ton bulker. But if you look at the way this panned out, actually, it went down during this period when fuel was very expensive in the early 90s. It went down. In the early 80s, I'm sorry, it went down. Then, once the price of fuel went down again in the 80s, it started to go up again. So you see the industry completely stopped paying attention to fuel here. And then, since the last 3 years, it's gone down a little bit. But generally speaking, the fuel efficiency of these ships has not changed since 1976, which is a ship ordered in 1974. So before we pat ourselves on the back too much for our stunning achievements, you might take it to wonder what was actually going on. I just repeated the analysis for Aframax tankers. Same sort of thing. This was a bigger sample of 390 ships. And you get the same sort of analysis. It went, the consumption went up a bit as the fuel price went down, and then since then, it was stable for a bit, and I guess it's come down a little bit. But really, this, this is not showing a very great contribution from the sort of propulsion and engine and hull efficiency side of the business on the face of it. Now, this is not I'm not putting this forward as a scientific analysis, but it's, it's based on the best data that's available. Could you do more? Well, I thought the other thing it would be interesting to do was to see how we compare with the car industry. So in order to do this, I changed ships again, and I took a Panamax container ship and a Panamax bulker, and I got all the new deliveries each year since 1999 and worked out the miles per gallon that they did. I mean, it's very high, actually. And I turned that into an index. So this index is the is an index of the fuel consumption in miles per gallon. So it goes up. If it goes up, you're doing better. It's the obvious opposite. So going up is good, going down is bad. And they both did about the same. It's the same pictures coming out in all of them. Not much, and then a bit of an increase lately. So then I thought, well, how did a typical car got on? So I went to Autocar website, and I downloaded the fuel consumption of a Ford Focus Z-Tech. Okay, this is 1.6 litres. As far as I know, it's the same ship, same car. Each year, I did that each year from 1999, and then I turned that into an index of miles per gallon. Actually, it starts off at 39 miles per gallon. So what do you think the car industry's done? Okay, I'm going to show you. Actually, until 2010, it did pretty much the same as shipping. They weren't paying much attention either. You bought a Ford's 1.6 Z-Tech, and it was 39 miles to the gallon. In 2011, it went up. The index went to 120, and in 2012, this year's model, 140. It actually, instead of 39 miles to the gallon, it claims 56 miles to the gallon. They've cut the engine size from 1.6 litres to a three-cylinder 1,000-cc engine. They've taken, I believe, they've cut 140 kilograms weight off the size of the petrol engine compared with the diesel. And I don't know what other magic. But I think the message in this is about resources. I mean, the Ford Motor Company has a massive research capability. And I look around the shipping industry and I wonder, who got together a coordinated team in 2005, 2006 and said the price of petrol's going up, it's going to keep going up. How are we going to address every aspect of the motor car in order to produce a better vehicle? And I'm sure that's what I haven't asked them, but I'm sure that sort of thing happened because that's what motor car manufacturers do to survive. I can honestly say I really don't think that was going on in the shipyards in 2006 because they were, I mean, I can tell you for sure it wasn't because you were on your knees to get a berth for any old design for a capesize, I watched our brokers. But I think there's a moral in that, which I will leave that thought with you. So what do we do about this? And I'm nearly at the end of my time, actually, so I can't remember what time I started, but I hope it's not too long. I think there's a problem in all of this. I'm an economist, so I'm not going to tell you how to design engines, thank God. But there is something that came to me as I was preparing this paper, and it's the way we look at speed in the shipping industry. In the Clarkson register for 50 years, we keep a register of the characteristics of ships, and other people do the same. And in that register, we record the speed of the ship, the design speed of the ship, and the consumption. And that's the way it's always been, and that's the numbers you'll find today in the register. I think this suggests that a ship has one speed. And I think this is absolutely ludicrously unhelpful when you actually, having sat through Captain Cooper's session this afternoon, we had a 30-minute chronicled account of the horrors of today's ships when you try to operate them at anything other than the design speed. They are simply not designed for it. They are, I would suggest that as a business, we are actually designing ships for a specific speed. And I think we should be regarding speed and consumption as not as parameters, but as variables. I think these are the things and what you're trying to do is view the ship as a rubber band which can expand its transport capacity or reduce it, depending on two key variables. And the two key variables are the two that I mentioned earlier. First of all, the speed of the ship, and secondly, the consumption of fuel, the price of the ship, and the price of the fuel. And if you put those factors together, then you actually have a challenge to find you can actually use a variable speed ship to arbitrage costs. Because actually, when the market is $180,000 a day for a Suezmax, you want to go 17 knots. When the market is $3,000 a day for a Suezmax, you want to go 6 knots. And that's your starting point. That's not your end point. That's the beginning of your analysis. It's what the Ford Motor Car company would sit down and start looking at, frankly. And to deal with this, I'm going to show you this. I'm always going to guarantee you won't understand what I'm on about, because I have to sit down and look at this chart for about half an hour before I can understand it too. But nevertheless, let me try. On this axis, we've got a change in cost as the ship slows down. So the cost may go up or it may go down when you slow the ship down. And this is the ship cost if the charter rate's $30,000 a day. So actually, and you're looking at the changes in cost in $1,000. I think this is in 1 knot increments. And I forget what the time period is. But what's going on here is that as you slow the ship down, the cost actually increases because the ship's going slower, right? So you need more days to do the same voyage. And if it costs $30,000 a day, your cost goes up, right? It's just arithmetic. Oh, it is in a spreadsheet. I'll send you the spreadsheet. So this is the curve at $30,000 a day, okay? Now, this is the same analysis, but the ship now only costs $15,000 a day. So the cost goes up, but the overall cost is much less because the ship's cheaper, okay? Now, let's stop looking at the ship. Let's look at the other big cost, which is the cost of fuel. Bunkers, if bunkers cost $1,500 a ton, then the slower you go along here, the less you spend on bunkers, right? And so this shows you your cost reduction. And if the cost of the bunkers is only $200 a ton, then the curve comes down here. Now, the point is that your optimum position for the ship is determined by the intersection between these curves. If bunkers are $1,500 a ton and the ship costs $30,000 a day, you want to be there at about 10 knots on this analysis. If the bunkers are $200 a ton and your ship cost is $30,000 a day, you're there. If your bunkers are $200 a ton and your ship is $15,000 a day, you're there. And on this one, it's $1,500 a ton and $15,000 a day, you're there. So you're going very slow then. And so those, I'm not saying this is the only analysis or even a correct theoretical analysis, but it's an illustration of doing a calculation. And if you do that, you can divine this area. And that is what I call the cost design matrix. In other words, this is the area within which you're trying to design the ship to operate in a way that won't cause Captain Cooper to blow his top, right? Because he was very upset about the fact that you haven't put a, you get down to here and he's afraid you're going to design a ship that will only operate here, and then when he gets on a lee shore, puts his foot down, but it's only got a 3,000 horsepower engine, and it can't get off. So, of course, what I'm saying is that when you look at the whole design matrix, then you look at what happens when you go slow, but like the Ford Motor Company, you're also looking at the fact Captain Cooper, or the owner, wants to go 18 knots when you can make $138,000 a day. You want the ship to do all of these things. Now, the ship can't do all of these things, but the challenge of technology and economics combined is to try and produce the ship that will do as many as possible as well as possible. And that basically is the cost strategy. Now, I thought I'd try and illustrate in a very crude way whether this does help you financially. And so what I did was I set up a little simulation model for an Aframax tanker to work out whether, in fact, if you had a ship that would go very slowly using that previous model, that went slowly in a bad market and fast in a good market, and slowly when bunkers were expensive and fast when they were cheap, if you did that, could you save money? And it was a bit of a complicated thing to do, and I was in a hurry. So all I did was just say if the bunkers are more than 28%, I think, of the total fuel cost of the ship, then it will go fast. If it's more than 28%, sorry, it'll go slow. If bunkers are less than 28%, then it'll go fast, right? Okay, and so and this is the amount of the transport cost of oil in that Aframax tanker over the period since 1976, if you just go at the maximum speed all the time. And if you apply my little model that it slows down when oil's expensive or when ships are not earning very much, and what happens is you do get you do find that these bars show you the modelled result, and there is a saving there. It's not a massive amount. This is not an optimised model, but it saves you 4%, which at least proves that you can save something. It's better than a poke in the eye. So I'm sure that you clever people could do much better than that. Right, so let me just give you my conclusions. I'm sure you're had enough and want to go home. I have to say I'm so grateful to those who sat all through the day and have turned out yet again. I think this is you're troopers. I think ship designers have spent the last 50 years surfing the globalization wave by designing bigger surfboards. That's really what we've done, I think that's what the industry's done. And it's easy and it's straightforward and it suits the customers who want something. They love a ship that's the same as the one they had last time, I mean, I think that's very much in the shipping ethos. We are facing a revolution, whether we like it or not, we're facing a revolution in fuel costs, which, if it goes on, and I think most people believe it will go on, means that you're not going to be able to just do the surfing big ships, a bigger surfboard thing. You're going to have to actually, do something about the power consumption of the surfboard as well. We've had our dress rehearsal. I think the 80s was a dress rehearsal. I think this might be the real thing, Economics principles tell us that fuel consumption and speed should be the dependent variables in the design model, not the parameters. You don't sit down and design a 16-knot Suezmax tanker. You design a flexible tanker that can operate effectively in all circumstances and not give Captain Cooper gastric ulcers, To avoid producing white elephants, I think this flexible engineering can demonstrate an ability to work with changing economic scenarios. And I think if you can do that, you can win the support of ship owners who use these ships, because I think once they, if this was on offer, It's better than an eco ship. It's a ship designed to do what we all know ships actually are supposed to do, which is adapt to the market, to slow down and to speed up and to be flexible. And I was, you know, I was very struck by Captain Cook. It's always great when you hear someone who's hot from, you know, the hot seat and he's got all that angst and, you know, he knows what it's all about. And I wouldn't dare smoke on his ship, that's for sure. And I think that we need to fix his problems for him because I think what he wants is a flexi ship. Ladies and gentlemen, Chairman, Mr. Adair, thank you very much for your attention.
Are there any questions from the floor? Yes, a gentleman here.
Graham Calder, Gulf Oil Marine. Just harking back to at the very beginning, the issue of the SD-14. When they were built, it was said they were built to be run by people from the villages, and they meant the villages in Greece. So with basically minimum technical input. How do you see the modern seafarer with a flexible ship? Because I think we've been guilty of de-skilling, if you like, the ship operator in many instances. The
more you think about the SD-14 example, it is going back to, there was actually quite a lot of product development at that time. There's 4 or 5, maybe 6 shipbuilders in the market for it. Of course, IHI with the Freedom. Massive competition, and I think the builders really did crawl all over that ship to come up with one that rang the bells on what owners wanted to do. And I think really part of what I'm saying is take a fresh look at what customers really want. Because I sense walking around, you know, I visit shipyards, I visit owners, I visit lots of different people, and everybody's waiting for someone else to tell them what the right ship is. Because, you know, you go to the shipyards and they want the ship owners to tell them, and the ship owners, and I think that's, you know, the problem we have with the technology today. I think my answer to that is I don't know, but I do think that if you were the Ford Motor Company designing a ship, you would look very hard at where you position yourself on onboard equipment, ergonomics, you know, the trade-off between technology I mean, let's face it, shipping is not massively ahead in IT technology. I mean, most of you in this room have probably got more technology in your pocket than you've got on the bridge of the average container ship, you know? I mean, iPhones are amazing, and that technology is still there to be harvested. So I think my answer, rather than answering you specifically, is to say that we need a system that looks more systematically at that, and crewing is part of it. And I think sort of we got a bit out of the habit of it, really.
Do you think that there's a chance that the shipping industry could get itself together to have that, if you like, committee overview that says this is what we should be doing because this is what the motor industry is doing, that kind of thing? Or are we too fragmented?
Well, I hate to say this, but when I started writing this paper, having sent the title off in a BlackBerry email and think, what am I going to say? I started from the preconception that actually the answer was no, we're not going to deal with change, that actually we don't have much technical resources. I mean, over the shipyards have been through 10 or 15 years where, you know, who have you got in the design department? It's not a lot of resources. And I think that there is, and shipping companies, you know, I know 1 or 2 shipping companies who have a technical director, but not many. I mean, we were chatting at the break about Marshall Meek at Blue Funnel, and I mean, he had about 25 people. And I don't know, he had a great big department. So I think we, you know, I think maybe, could I put it to you this way, that we've been building bigger surfboards hasn't taxed our technology very much. I think the next phase is harder. I think a lot of things in the next phase are going to be harder. And yes, I think we do need to do it. And no, I don't think we've got a very strong capability at the moment. There's a lot of groundwork to be done.
Sam Kimmin, Sustainable Shipping Initiative. Do you think it's a case of those shipping companies that do get together, collaborate, build their innovation capability, they'll be the ones who survive, and it will be a case of survival of the fittest?
I think they'd probably be investigated by the EU for antitrust, actually. But don't take my word for it.
But there must be a way of, if everybody sits in their silos and innovates independently, we won't get anywhere.
I think. Look, it doesn't take a lot of resources. You have to take it one step at a time, and I mean we don't have Boeing and we don't have the Ford Motor Company in the shipping industry. We have some very big and articulate classification societies, including our sponsors this evening. We have a lot of, we have design agencies and so forth. I think that, you know, if you can sell it, you know, it's a capitalist world. Shipping is the most capitalist of anything. If you're doing something worth doing and the owner will pay for it, you know, then I think it'll happen. And so I think really the question is you've got to put your goods in the shop window first. And I think my argument is not we can't do it. My argument is we haven't been used to doing it and we haven't got anything in the shop window at the moment.
My final duty is a memento, Martin, for your lovely lecture this evening, which you all enjoyed very much.
Oh,
Thank you very much.
Thank you so much.